Then letter series. Letter series also known as alphabet series or letter sequence. So letter series also known as alphabet series or letter sequence is a subset of logical and analytical reasoning that involves a systematic arrangement of letters based on a certain pattern or rule. It is a crucial component of various competitive exams, intelligence tests, and logical reasoning assessments. So let's have an introduction about this topic. Letter series is a form of non-verbal reasoning that focuses on recognizing and deciphering patterns or relationships among letters. Success in solving letter series problems depends on the ability to discern these patterns and apply logical thinking to determine the next letter in the sequence. Then types of letter series. Forward series. In a forward letter series, letters are presented in a specific sequence and the task is to identify the next letter following the pattern. For example, A, C, E, G, I, where the pattern is advancing by 2 letters in the alphabet. Then backward series. In a backward letter series, letters are represented in reverse order and the challenge is to identify the next letter according to the pattern. For instance, a pattern like this, Z, X, V, T, R, where the pattern is working and it's moving back 2 letters in the alphabet. And missing letter series. In this type of series, a letter is omitted or missing in the sequence. The objective is to identify the missing letter according to the pattern. For example, A, C, E, I, where the missing letter is G. And repeating letter series. Repeating letter series involves patterns where certain letters are repeated at regular intervals. The task is to identify the next letter following the same pattern. For instance, A, B, A, C, A, D, where A is repeated before the next letter in the alphabet. And mixed series. Mixed letter series combines various patterns within the same series. The challenge is to recognize and apply different rules for different parts of the series. And common patterns in letter series. Alphabetical order. Series can follow the natural order of the alphabet either in forward or backward direction. Then reversal. Letters are reversed or presented in reverse order. And alternative letters. Every other letter in the alphabet is used, skipping a letter between each displayed letter. Vowels and consonants. Series can be based on the alternative between vowels and consonants. An alphabetic shift. Letters are shifted by a certain number of positions in the alphabet. Letter addition, subtraction. Letters are added or subtracted from the previous letter based on a consistent pattern. Then strategies for solving letter series. Pattern recognition. The key is to solving letter series is identifying 2 letters or rule governing the series. Careful observation and analysis are essential. Identifying breaks. Look for any breaks or changes in the pattern as these can indicate a shift in the series. Then testing hypothesis. When you identify a pattern, test your hypothesis by applying it to subsequent letters to confirm its accuracy. And practice. Regular practice with a variety of letter series example is crucial for developing proficiency. So letter series problems is an individual's ability to identify and apply patterns and rules within a sequence of letters. They require logical reasoning, pattern recognition, and analytical thinking. Developing skills in solving letter series can enhance one's problem solving abilities, critical thinking, and performance in competitive exams and cognitive assessments. So, number series is a fundamental aspect of mathematical reasoning and logical analysis. It involves a systematic arrangement of numbers based on a certain pattern or rule. Understanding and solving number series is essential in various academic, competitive, and problem solving contexts. So let's have an introduction. Number series is a component of nonverbal reasoning that focuses on recognizing and deciphering patterns or relationships among numbers. Success in solving number series problems depends on the ability to discern these patterns and apply logical thinking to determine the next number in the sequence. Then types of number series. Arithmetic series. In an arithmetic number series, each number is derived by adding or subtracting a fixed value known as the common difference to the previous number. For example, 2, 4, 6, 8, 10, where the common difference is 2. In geometric series, in a geometric number series, each number is derived by multiplying or dividing the previous number by a fixed value known as the common ratio. For example, 2, 4, 8, 16, 32, where the common ratio is 2. Square series. In a square number series, Each number is the square of the natural numbers in ascending order. For example, 1, 4, 9, 16, 25, where each number is the square of consecutive natural numbers. Then cubical series. In a cubical number series, each number is the cube of natural numbers in ascending order, where each number is the cube of consecutive natural numbers. Then Fibonacci series. The Fibonacci series is formed by adding the two preceding numbers to generate the next number. For example, 0, 1, 1, 2, 3, 5, 8, 6, 13, where each number is the sum of the two preceding numbers. Prime number series. In a prime number series, each number is the prime number, which means it has no divisors other than 1 and itself. And quadratic or polynomial series. Quadratic or polynomial series involves complex equations and their solutions to derive the numbers in the series. Then strategies for solving number series. Pattern recognition. The key to solving number series is identifying the pattern or rule governing the series. Careful observations and analysis are essential. Then identifying breaks. Look for any breaks or challenges in the pattern as they can indicate a shift in the series. And a testing hypothesis. When you identify a pattern, test your hypothesis by applying it to subsequent numbers to confirm its accuracy. And regular practice is necessary. Then application of number series. Academia. Number series are used in academic disciplines like mathematics and statistics for research and problem solving. Competitive exams. Number series problems are common in competitive exams and aptitude tests assessing in individuals mathematical reasoning. Data analysis. In fields like data analysis and statistics, recognizing patterns in numerical data is essential. Puzzles and games. Number series are a common feature in puzzles and games requiring players to decipher the sequence. Number series problems are an integral component of mathematical reasoning requiring pattern recognition, analytical thinking, and logical reasoning. Developing proficiency in solving number series is essential for enhancing problem solving abilities and critical thinking, which can be highly valuable in academic, professional, and competitive contexts. Types of reasoning. We just mentioned number series. Number series is a subset of mathematical reasoning that involves a systemic arrangement of numbers based on certain rule or pattern. Arithmetic number series is there, geometric number series, square number series, cubical number series is there, Fibonacci series, then prime number series, quadratic or polynomial series. Then it's essential to understand this. Letter series we just mentioned. Next type, relationships. Relationships are fundamental to human experience and understanding. They encompass connections and associations between people, objects, and concepts and various elements of the world. Analyzing and comprehending relationships is vital in fields ranging from psychology and sociology to mathematics and philosophy. So, relationships refer to the connections, interactions, and associations between entities, whether they are individuals, groups, elements, or concepts. The study of relationships seeks to understand how things relate to one another, the nature of those connections, and their significance. Then, types of relationships. Human relationships. These encompass interpersonal connections between individuals, such as family, friendship, romantic, and professional relationships. Then, social relationships. This involve connections within society, including cultural, community, and societal relationships. In mathematical relationships, in mathematics, relationships are expressed through equations, functions, and patterns that define the connections between numbers or variables. And cause and effect relationships. This denote the causal connections between events or phenomena. One event leads to another, which can be observed in various scientific disciplines. Synergistic relationships. In synergy, the combined effect of entities working together is greater than the sum of their individual effects. This concept is common in teamwork and economics. Then, dependency relationships. This exists when one entity relies on another for support, resources, or function. This can be observed in ecological system and economics. Then, abstract relationships. Philosophical and metaphysical discussions explore abstract relationships between concepts and ideas, such as the relationship between mind and body. Then, psychological aspects of relationships. Attachment theory. Attachment theory explores the emotional bonds formed between individuals, often in the context of parent child relationships. It examines how these attachments influence personality and behavior. Social exchange theory. Social exchange theory posts that individuals engage in relationships with an expectation of reciprocity and mutual benefit. It's a fundamental concept in understanding why people form and maintain relationships. Interpersonal attraction. This area of study seeks to explain why people are drawn to certain individuals and the factors that influence the formation of friendships and romantic relationships. Importance of relationships. Emotional well-being. Healthy relationships are vital for emotional and psychological well-being. Positive relationships contribute to happiness and reduce stress. Professional success in the workplace. Effective relationships are crucial for teamwork, collaboration, and career advancement. Then societal harmony. Relationships within communities and societies are the foundation of social harmony and cohesion. And scientific understanding in various fields such as society and sociology and psychology, relationships are studied to gain insights into human behavior and social dynamics. Then some other aspects related to challenges in relationships. Conflict and misunderstanding. Conflicts and misunderstandings can strain relationships, leading to emotional stress and discord. Then communication issues. Ineffective communication can hinder understanding and lead to misinterpretation in relationships. Then interpersonal problems. Differences in personality, values, and expectations can pose challenges in interpersonal relationships. Then dependency and codependency. Unhealthy dependency or codependency in relationships can lead to emotional or psychological issues. Then improving relationships. Effective communication, open, honest, and respectful communication is essential for nurturing healthy relationships. Then conflict resolution. Developing conflict resolution skills can help address issues without damaging the relationship. Then empathy and understanding. Emphasizing with others and seeking to understand their perspective fosters empathy and cooperation. Then boundaries. Establishing and respecting personal boundaries is crucial for maintaining healthy relationships. So relationships are a fundamental aspect of human existence, impacting our emotional well-being, professional success, and societal harmony. The study of relationships spans multiple disciplines and addresses various types of connections, from human and social relationships to mathematical and philosophical connections. Then mathematical aptitude, fraction, time, distance, ratio. Mathematical aptitude, fraction, time, distance, and ratio. Fractions are a fundamental concept in mathematics representing a part of a whole. So a fraction consists of a numerator, the number above the line, and denominator, the number below the line. The numerator represents the part you have, and the denominator represents the total number of equal parts in the whole. And operations with fractions, addition and subtraction. To add or subtract fractions, they must have the same denominator. If they don't, you need to find a common denominator. Once the denominators are the same, you can add or subtract the numerators and keep the denominator. And multiplication, to multiply fractions, multiply the numerators to get the new numerator and the denominators to get the new denominator. Division, to divide fractions, multiply the first fraction by the reciprocal, flip the version of the second fraction. Then time and distance. Time and distance problems involve the relationship between time, speed, and distance traveled. These problems are commonly used in physics, engineering, and everyday life to calculate travel time, speed, and distances. Basic equations. Distance is equal to speed into time. This formula calculates the distance traveled when you know the speed and the time it took. Speed distance by time. This formula calculates the speed when you know the distance and the time it took. Distance is equal to speed into time. Speed is equal to distance by time. Time is equal to distance by speed. This formula calculates the time it takes to cover a certain distance at a given speed. Problems in time and distance. Relative speed. When two objects move in the same direction, their relative speed is the difference of their individual speeds. Meet and overtake problems. These problems involve two objects moving in opposite directions or in the same direction but at different speeds. You need to calculate the time it takes for them to meet or for one to overtake the other. Then circular motion. Problems related to circular tracks or motion involve concepts of circumference and time. Then ratio. Ratio is a comparison of two quantities. It expresses how many times one quantity is contained in another. Ratios can be represented as a fraction with the numerator representing one part and the denominator representing the other part. Types of ratios. Simple ratio, a ratio that compares two quantities directly without any scaling. Compound ratio, a ratio that involves multiple quantities compared together. Then duplicate ratio, a ratio where the numbers compared are squared. Then proportions, ratios are fundamental in setting up proportions, which are used in solving many real world problems, including those in science and finance. Next topic we'll be learning with the help of next video. Thank you for listening.